Hello everyone, welcome to 10-Minute Physiology. In today's video, we're going to review acids and bases. So with that, let's give it a go. So I'd like to start off by first describing to you what a Bronsted acid is. So let's just say you have a beaker, and this beaker is filled with a solution. And then you take some hydrochloric acid and put it in the solution. Now, since hydrochloric acid is a strong acid, it is going to fully dissociate. So therefore it dissociates into hydronium ions and chloride ions. Now the hydronium ions are going to be the most important because these are the ones that are going to acidify the solution. So Bronsted acids are anything that can donate a proton or hydronium ion. So now let's talk about a Bronsted base. So imagine you take some sodium hydroxide, put it in the same beaker. Since sodium hydroxide is a strong base, it fully dissociates. The hydroxide interacts with the hydronium, which will then form water. So in other words, a Bronsted base is anything that can accept a proton. So now that we know what Bronsted acids and bases are, let's talk about pH. So what is pH? So pH is the concentration of hydronium ions in a solution on a logarithmic scale. So pH can be calculated using this equation here, and we can look at different pH values by looking at the pH scale. So the three main numbers that you should know are 0, 14, and 7. So 7 is a neutral pH, and any pH that is below 7 is considered acidic. And any pH that is above 7 is considered basic. So another topic that we're going to talk about are what are buffers. So buffers are weak acids or bases that resist large changes in pH. And they typically have this chemical formula, this generic chemical formula, where you have the weak acid and the conjugate base in equilibrium with each other. Now, these weak acids and weak bases are different from strong acids and strong bases because the weak acids and bases don't fully dissociate into ions, whereas strong acids do. So now what we're going to do is we're going to see how we can calculate the pH of a buffer system. So if you were to take your weak acid and you were to use this chemical equation, you can make your acid dissociation constant. You can calculate that value using this equation. So then what you can do is take the log of both sides, and then using the laws of logarithms, you can form this equation. So after you have this equation, what you can do is you can rearrange certain things in order to find the pH. So you're going to bring log of hydronium ions to this side and log of Ka to this side, giving you this equation. Now you can simplify this equation into the last one, which is this equation. So this is the Henderson-Hasselbalch equation, and it's used to calculate the pH of a buffer solution. So now that we have these basic concepts down, I want to do some practice questions. So take some time to answer these after I read them. So the first one is, what is or are the Bronsted bases in water? So in this question, you have to remember that Bronsted bases are anything that can accept a proton. So the things that can accept a proton are the sodium hydroxide, which we talked about, as well as the acetate, so A and C, so the answer is E. So the next question is, a solution of hydrochloric acid has a pH of 4. How much more or less is the concentration of hydronium ions in a solution of hydrochloric acid that has a pH of 2? So pause the video and try to answer this yourself. So remember that pH is a logarithmic scale, and when you go up from a pH of 1 to 2, this means that the concentration of hydronium ions has decreased by 10 times. So if you go from a pH of 4 to pH of 2, 4 minus 2 is 2, and since the pH decreased, this means that the solution has 100 times more hydronium ions than the original. So the third question is, which of the following can act as a buffer in water? So it's important to realize that buffers are weak acids and weak bases. So hydrochloric acid and sulfuric acid cannot be a buffer because they are strong acids. So the only choices here that are weak acids are C and D. The fourth question is, a solution has a pH of 6.8. Is the solution acidic or basic? So the answer is acidic because remember, anything that's below a pH of 7 is going to be acidic. And then the last question, a weak acid has a pKa of 6.1. Inside the solution, you have 24 millimolars of the conjugate base and 1.2 millimolars of the weak acid. What is the pH of the solution? So I hope you calculated it, and the way you calculate this is using the Henderson-Hasselbalch equation, which we derived, and if you do that, the answer is 7.4. So I hope this video helped you understand these introductory concepts, because these are going to be seen over and over again in this playlist for the respiratory unit. So I hope to see you in the next video, and I thank you for watching.